Some of you have asked this already, so because you have a long weekend this weekend, today is the last day of learning new material for the year.
Yeah. Woo.
So Tuesday and Wednesday next week are reviewing for the Chapter 12 test, which is on Thursday. And then that means next Friday, the following Monday, and then that Tuesday would be reviewing for the final exam. I believe 1, 3, and 5 are the last day of school, the 8th. So yours would be that Thursday, the 8th, for your final. Is that your question? No.
Oh my God.
We still have 2 weeks, but they're both short weeks.
So all week next week then we're going to be doing?
Tuesday, Wednesday's review for the test.
For Chapter 12.
The Chapter 12 test is Thursday.
Oh,
Chapter 12 test is good.
Yeah. All right. So today's lesson, as long as we can get through it, is pretty short. Well, second hour had basically enough time to get their assignment done. So if you don't want an assignment, then we should be able to get to it. What?
Okay, we're ready.
Oh, wow.
All right, so circular and periodic functions is what this first part of 12.6 is covering. We will not finish it, but that's okay. I knew with this last unit we would get to whatever point we had time for. But if you are taking trig pre-calc next year, sine and cosine and tangent, trig functions are periodic functions. So this is setting you up to understand what a periodic function is. Even though we're not going to get to actually graphing sine, cosine, and tangent, but you'd have at least that background knowledge going into next year. So the unit circle that I had you fill out part of, we just filled out the common angle measures on it, but the unit circle is defined as a circle with a radius of 1 unit centered at the origin on the coordinate plane. And you can use a point P on the unit circle to generalize sine and cosine functions. So it explains what sine and cosine of theta are equal to there. But if you look over at the circle, notice the terminal side for some angle theta is here. And this is something we've done before where you ended up making, based on a point on the terminal side, you dropped down a side to create a right triangle to that x-axis. And that means for the triangle, the horizontal side here is the distance x to get to some point xy on this circle here. This vertical side would be the distance y. The radius is the hypotenuse of that triangle. And the radius is 1 for the unit circle. So how sine and cosine are defined here? Sine of theta we know is the opposite over the hypotenuse, so the opposite side is y. The hypotenuse is the radius, which is 1. So on the unit circle, sine of any angle theta is equal to y. And then cosine of theta, cosine is adjacent over hypotenuse. The adjacent side to theta is x, hypotenuse again is the radius, which is 1. So cosine of theta is just x. So the values of sine of theta, cosine of theta are the y-coordinate and the x-coordinate, respectively, of the point where the terminal side of theta intersects the unit circle. So where it says here that point P has the general coordinates x, y, we could rewrite that and think of the ordered pair as representing the x-coordinate is cosine of theta, and the y-coordinate is sine of theta. And then from that unit circle, as the terminal side travels around the unit circle, and it could continue going around and around and around. Cosine of theta equals x, sine of theta equals y. These are both functions of the angle theta, and because they're defined using the unit circle, they're called circular functions. So the first example that we're going to go through, you'll have examples where it gives you the terminal side of angle theta in standard position intersects the unit circle at some point. So this point is square root 7 over 4 and then 3/4. Find all 6 trig functions of theta. So we're going to find sine, cosine, tangent, and their reciprocals. So when you are given a point and you are told that that point is on the terminal side of the angle theta and it's intersecting the unit circle, you know the x-coordinate is the value of cosine of theta, the y-coordinate is the value of sine of theta. So I can say sine of theta is equal to the y-coordinate, which is 3/4. Cosine of theta is equal to the x-coordinate, which is the square root of 7 over 4. And then use this information to find the other 4 trig functions. One thing that I want to point out with this type of problem is for you to think about which quadrant this point falls in, quadrant 1, 2, 3, or 4, and then in each quadrant, what trig functions are positive. So in quadrant 1, what trig functions have a positive value? All of them. In quadrant 2, sine is positive. In quadrant 3, tangent, and in quadrant 4, cosine. So all students take calculus. Those are the trig values that are positive in those quadrants. So if you look at this, since x and y, or respectively both sine and cosine of theta are positive, if both sine and cosine are positive, this point has to fall in quadrant 1. So that means when you find the remaining trig functions, all of your answers for this problem would be positive. So pay close attention to that if one of your coordinates is negative, so that you know which of the other trig functions you're finding should be negative. Also, to find, say, tangent of theta, we'll find that next. You could sketch a triangle given this point, but you don't have to. Just based off of these ratios, I can identify what the opposite side is equal to, what the adjacent side is equal to, and what the hypotenuse is equal to. So if sine of theta is opposite over hypotenuse, the opposite side must be 3, the hypotenuse must be 4. And if cosine of theta is adjacent over hypotenuse, the adjacent side must be the square root of 7. So then, if I wanted to find tangent, what ratio is tangent? Opposite over adjacent, so tangent of theta is 3 over the square root of 7. However, we can't leave it that way. It's not simplified. How do we simplify this? So then 3 square root 7 over 7 would be the simplified value for tangent. And then we can find the reciprocal functions. The reciprocal of sine of theta is cosecant of theta, and that's 4/3. Reciprocal of cosine of theta is secant of theta, and that's 4 over the square root of 7, which we'd simplify like we did for tangent, multiply by square root 7 over square root 7, so 4 square root 7 over 7. And then cotangent of theta, we can go back to how we originally wrote tangent, 3 over the square root of 7, take the reciprocal, cotangent is square root of 7 over 3. So the main main goal is recognizing that on the unit circle, the x-coordinate is cosine of theta, y-coordinate is sine of theta, but then you can use that information to find your remaining trig functions. Questions on part 1, for example 1. Okay, then next is defining what a periodic function is. So a periodic function has y values that repeat at regular intervals, and one complete pattern is a cycle, and the horizontal length of one cycle is called a period. So if you look at, this is the same function, they're showing it as a graph, and then they're showing it as a table. So you can see for this graph, it starts at the y value 1, goes down to -1, back up to 1, and then it continues that pattern as you move to the right on the x-axis. So 1v is a cycle, because then that v continues to repeat, and then 1 period would be the length of that v. So it starts at the x value 0, ends at the x value 360, so the period is 360 degrees. You can see that from the table as well. So from 0 degrees, where the y value is 1, the next time the y value becomes 1 is at 360. So you're seeing how long it takes for those y values to start repeating. So in example 2, you'll have some graphs that you're given where you have to determine from the graph what the period of the function is. So look for the pattern that you see. Here you can see the pattern is going down, a horizontal segment coming back up, and then that starts to repeat. So the period is the length along the x-axis that happens, and the pattern starts at the x value 0 and ends at the x value pi. So the period is pi. Questions on example 2? How do you know the period is pi? The pattern starts at the x value 0 and ends at the x value pi. So that distance is pi. Other questions on that? Okay, so then the last example, again, this is giving you background knowledge if you are at any point in your life you're going to take something that involves trig. Setting you up for when you learn to graph sine, cosine, tangent as they are periodic functions, but an example of where a periodic function could occur here, rotations of wheels, pedals, carousels, objects in space, these are all periodic. So if you ever wanted to study some sort of rotation over time, that would become a periodic function, which can then be modeled with a trig function. But the pedals on a bicycle, for example 3, rotate as the bike is being ridden, and the height of a pedal is a function of time as shown in the figure. So this didn't copy very well, but what they're showing is, this is a bike pedal here. Like I said, the actual pedals didn't copy too well. And they're showing that as that pedal goes around, as you're riding the bike, off to the side is showing at what height the pedal is with respect to time. So in part A, it does make a table showing the height of a bicycle pedal at 0, basically 0 through 3 seconds at half-second intervals. So if you look at the diagram, at 0 seconds, the pedal is starting up here at the top, which would be at a height of 18 inches. And then as the bike is being ridden, that pedal is going around counterclockwise here. So at half a second, this is where the pedal would be, and that height is 11 inches. And then after another half second, so at 1 second, the pedal is now downward. So That's at a height of 4 inches. After another half second, the pedal is back at 11 inches for the height. And after another half a second, at 2 seconds, it's back up to where it started, so it's at a height of 18. So then what would the height be at 2.5 seconds? 11, and at 3 seconds, 4. So there's our table. Then it says identify the period of the function. Ideas from looking at the table, what the period would be. Not half a second. So remember, a period is, in this case, it would be the length of time that it takes for one cycle of the pattern. So you can start to see where the pattern, after 2 seconds. So after 2 seconds, that's how long it takes that pedal to go around once, and then it's going to keep repeating that pattern. So 2 seconds is the period. I'm not saying this 2 seconds specifically is the period, the length of time, 2 seconds is the period. So from 18 to 18, that's a length of 2 seconds. Even if you did it from 0.5 to 2.5, that's still 2 seconds. That's not a full cycle. That's not a full pattern. So then in part C, you're graphing the function, letting the horizontal axis represent the time t, vertical axis represent the height h in inches that the pedal is from the ground. So I know I have x and y on here. I can change that. The x-axis is time. The y-axis is the height of the pedal. But this will allow you to visualize what this would look like as it was graphed out. So at 0 seconds, the height was 18. At 0.5, the height's 11. At 1, it is 4. 1.5, it's at 11. 2, it's at 18. 2.5 is 11. 3 is at 4. And when you draw this, don't draw it like a V so that it's super sharp corners. Draw it more as a smooth curve, since as you're pedaling, the pedal's going around most likely in a smooth motion. So more rounded and not like a V. And it would continue after 3 seconds. We're just not graphing the entire thing. So again, introduction, those of you taking trig next year, this is the shape of a sine or cosine curve. This could be modeled if we wrote an equation for this curve. We could write a sine or cosine function to model it. So it's getting you a little bit of background knowledge to understand periodic functions, because that's what trig functions are. Any